Okay. Okay. Although example 13, I asked you guys to go home to read, but I think I need to highlight this one because yeah, one of your exam question will related to round body. Okay. Yes. And also will be very related to civil. Means I will use tractor, I will use all this machine for analysis. Okay, so back to this one, example 13. So you have a round body and then you have a additional moment added to the body. Okay, so means you need to add one more moment in your calculation. And then radius was given. So mass was given, radius of gyration kg was given. And if additional 15 Newton meter coupled moment was applied, determine acceleration of the mass of the center G here. So you need to calculate the alpha, right? This one is not alpha, this one is the A. So you need to convert the omega alpha into A. So coefficient static kinetic between the wheel, you have two. So you have static coefficient and kinetic coefficient. You have to able to, don't use the wrong value when you calculate. Static means before moving. One is moved, then you have to use K already. Okay, so when you draw the free body diagram, G, weight, all these are standard. I just need to highlight, after chapter 6, all your free body diagram must be draw according to the center of mass. So previously, chapter 1 until chapter 5, every time if you draw central, if you put an object and in your free body diagram, if you draw your W like this, you still correct. But when it comes to rigid body, if you draw like this, it's not at the center of mass, you get wrong answer. It must be go through the center of mass, then only get the correct answer. Yeah, so rigid body, if you're given center of mass, all the weight must go through the center of mass. Don't simply go and draw one that outside the center of mass. Okay, so then you focus on point A, because the question asks you the acceleration of the mass at the center G, and then there's a contact point A there. Okay, so every time there's a contact point, they always have a force and a Newton, not Newton, normal forces. So every time there's a contact surface, they always have a normal forces. And since this question very obviously give you the friction coefficient, there must be a friction force there. All right. So this one rotate clockwise. So when you block clockwise, the force will be this way. Right. The friction will be against the rotation. Okay. So you need to match this one and this one. Okay. Then you match your alpha and omega same direction. Okay. Your kinetic diagram. Now your kinetic diagram, your acceleration also, because the question asks you about center of gravity. So your acceleration will be at the center of center of mass. Okay. So that is the only thing I need to highlight every time you draw free body diagram or kinetic diagram. You will always have to pass through central mass for rigid body. All right. Then a moment of inertia now. Since you're given the gyration K there, you need to use this formula. Okay, Ig equal to mkg square. Fixed already, yeah? This one is fixed already. So you substitute, all right? You get. So the only unknown later you need to solve is all this lah. Okay. Normal force, friction force, what is the acceleration of the body at the point G, what is your alpha? Okay. So equation of rigid body, you cannot run away from this three equation or this two equation if you want. So mg equal to ig alpha and F equal to ma. All the force equal to ma. Break this one into y and x direction. And if this one, because this one you move in the flat surface, so it's x and y. But if the thing rotate, then you focus on tangent and normal direction. Okay. So moment at point G, you put your focus on point mass, central mass. So your W, the W gone because the D is 0. So you N also 0 because it passed through the central mass. You only see FA, right? Okay, then there's one additional, just need to highlight lah. You don't forget the question give you additional moment. Okay, 50. So that's why there's a 50 there. So normally the careless mistake is the additional information was not added into the solution. You know how to do all these moments, but you forget there is an additional moment given. Same with your incoming final exam. There will be additional moment given in the question. Okay, so okay, so right hand side you just substitute based on calculation. Ig equal to mk square. Okay, the purpose of giving you the gyration is to calculate the Ig. Then convert all the force in x-axis, right? Fa, mag, that way. So what about your mgy? 0, because your object do not move up. Your object move to the x direction only. So the second one is equal 0. Okay. So you solve these three simultaneous equation, you're able to find. Okay. So three equation, but you have 4 unknown. So you need one more equation. So usually it's the moment, right? So these three equation defined just now. So you need another one. So you need to convert link with omega alpha to get the acceleration. So in this case, your A equal to this 1.36. Okay. 0.36 multiplied by alpha or alpha R, right? So once you get this equation, you can solve the remaining unknown. So you will get the remaining one. Okay. So acceleration equal to alpha R. Okay. So again, this one you have your tangent and normal acceleration. This one is omega square R. Okay. So your acceleration have two components. So this one is the tangent acceleration. Right? So in this case, it asks you to find whether you need to use which friction coefficient. So this solution required no slipping. So no slipping, your FA must less than the friction static coefficient and the normal force. All right. So in your answer, if you substitute your mu s 0.3 and Na, so this one 0.3 multiply this one, you get 73.6. All right. So if you use the static one, your friction force is 100 something. So your calculation is more than the static. So if your FA more than the static value, the wheel will slip as its roll. Right? So you can so we cancel the previous one. So the wheel will slip as its roll. So when it's do slipping, you need to use the kinetic coefficient already. So you need to restart your calculation, FA equal to mu K NA, and then you substitute back over here. Then redo the calculation. Okay, so you have a new set of answer. Okay, so it's a bit tricky if you have two friction coefficient there. You need to calculate the condition whether it slip or do not slip. In this case, you need to calculate the force of this one, FA. What is the value if you use the mu S or mu K? Okay. Okay. This one you need to review it again and again. This one, example 14, is also in chapter 6, rigid body. So there you have a body here, a wooden body, and you was hanged to two rope here, point C and point D. Both in equivalent position means stable, and given the mass 50 kilogram. 50 kilogram, you should put in the correct location, which is the center of the wood here, pointing down. So determine the tension of BD here, and the angular acceleration of bar immediately after AC was cut. So what happened if you cut this one? You need to analyze these wooden pieces will swing anti-clockwise. Okay, will swing anti-clockwise, and then you need to find the tension of BD. So again, you need two free body diagram, free body diagram and kinetic diagram. Start with the center of mass and then the point B. Weight will go through center of mass. The tension of cable will act on the B point pointing up, but there's no more forces at point A because it will cut away, right? Then kinetic, you know that kinetic, the acceleration in this case, right? You have X direction and Y direction, right? Okay. So this one, you have IG alpha, you have MG, Y. So there's a loss of constant again, but you still use the three famous equation, moment equation, F equal to ma. So moment at center of mass equal to IG alpha. So how to find the central mass moment? You close here, you only see tension at point B, multiply by 1.5 the perpendicular distance. Then IG, this one where you find from the table. The table, this is a rod shape at the center G point here. So you get 12 ml square and alpha. In this case, F equal to ma, there's no force acting at the x-axis, so 0. M was given, AGX was you need to find. Then Fy also same. Fy, you have two forces here, tension of cable and also the weight. Okay, then M is 50, AGY is negative. Why there's a negative here? Because it's go down and our y-axis positive go up. Okay, So just be careful on the positive, negative direction. Okay. So you can add a little bit more information when you cut Rob's AC. The body will swing anticlockwise. So you have alpha, and then omega is 0, right? So acceleration, when this one swing, you will have circular motion. So your angular acceleration at B will be v square over rho equals 0, right? Is 0 because AB only is a tangential component with direct along x-axis. Recall there's one more equation you learned before this, where your AG equal to AB plus the acceleration of your G slash B. This one you have a normal and tangent direction. So you put in the vector form, minus G, J. Your B is in x direction. And then alpha. Why alpha is positive K? Because it's anti-clockwise. You use your right hand rules. Right hand rules. This one, like this one. So your finger curve in, your thumb point out. So you get a positive K. Cross minus 1.5. Okay. Then your omega 0, and you solve for I and J. Okay. Then you substitute all the known value, you solve for the unknown. Okay. So this is chapter 6. Right. Let me stop the recording.